Several of you have mentioned having difficulty with Lesson 13, dealing with exponential functions, primarily kind of the application questions related to interest and growth and decay. So I've pulled several questions from the Newton assignments, and I'm going to kind of work through them. I think maybe some of the issue is how you guys are entering things into the calculator, so I want to try to demonstrate that for you as we go through the question. It's important that you read the question and that you read it carefully. So the first question says, a speedboat bought for $13,000 depreciates at 10% per annum, compounded continuously. What is its value after 7 years? And it asks you to round to the nearest dollar. Okay, so the first thing that I want to think about is, what formula do I need? And in identifying the formula that I need, if I go back and I read, and I can even scan a little bit, it says compounded continuously. So the fact that it's compounded continuously, I know that I want to use the formula A equals P times E to the RT. And so the second thing that I want to do, and it's usually what I do for any kind of interest problems or really any kind of word problems, is identify the pieces of information that I need for the problem. So if I go back and I read carefully, it says a speedboat bought for $13,000. Okay, so the $13,000 is my principal. That's how much money I spent out or how much money I put into the account. That, remember, the principal is kind of the initial amount. And then it says it depreciates, and that's a very, very important word, depreciates at 10%. So my rate of interest is 10%, which we need to convert to a decimal. So we do 10 divided by 100, and it's 0.10. And the fact that it depreciates, that means it's going down, and we indicate that mathematically using a negative. So the fact that it depreciates is what clues me in that my negative or my rate is negative because it's depreciating, the value is going down. And then the question says, what is the value after 7 years? So my time is 7. Now, it's important to realize that in this scenario, this is in terms of years. And so then it becomes obvious that I'm looking for A, the final value, or the final amount. So it becomes basically a substitution problem, and I'm going to plug the numbers into the formula. So I would have 13,000 times E, which is the Euler's number, okay, or the natural number, raised to the negative 0.10, because I put it in as a decimal, times 7. Now, for me personally, when I go to put this into the calculator, I like to walk it through the steps. I don't usually try to put the entire problem into the equation. So if I think about my order of operations as I'm entering it into the calculator, I would deal with the exponent first. So I would have 13,000 times E, and I'm going to multiply negative 0.10 times 7. Now, let me point out to you, remember the negative symbol is down here next to the decimal key. It's this little minus sign with parentheses around it. Okay, that's the negative sign. This gray button on the right-hand side is your subtraction symbol. Okay, so make sure you're using the right symbol. That gives us negative 0.7. Again, then thinking about the next step, I would then do my exponents, I need to do e to the negative 0.7. Okay, to get the E is in blue above the button that says LN on the left-hand side of your calculator. So I press the blue button first, then LN, and the E appears, and I'm going to enter the exponent. Again, I have to do negative 0.7, and I'm going to close the parentheses, and I hit enter. So I would have, at that point, $13,000 times, and I enter that decimal value there, which is 0.4965. 0.49658. Now it's really better to carry the whole decimal with you. So this decimal value of 0.4965853038 is in the calculator's brain. And so the last step is to multiply that by 13,000. So I'm just going to tell it to do times. See, it automatically puts in that decimal value times 13,000. And I enter. Okay, which gives me my final answer of $6,455, and it would be 61 cents. Okay, so I have $6,455.61. But notice here in the question, it asked me to round my answer to the nearest dollar. So if I round this to the nearest dollar, the 6 that's in the tenths place is going to bump it up so that my final answer is $6,456 when rounded to the nearest whole. Okay, a lot of it, guys, is taking your time, paying attention to the words, and then knowing which formula to use. You're given the formulas for the final exam. Okay, so you don't have to memorize them. Okay, you should also have them accessible during test 4. Okay, so the second question says an investment banker deposited $5,000 in an account earning a nominal 6% per year compounded continuously. How much was in the account at the end of 3 years, and round the answer to the nearest dollar. So here again, the first thing I'm going to start with is it says it is compounded continuously, okay, which means if it's compounded continuously, that I need the formula A equals P times E raised to the RT. And again, the next thing I want to do is I want to identify the information that's given to me in the problem. So again, I go back and I read, and it says the banker deposited $50,000 into an account. So that was the amount of money that he started with. So we started with $50,000. It says it earned a nominal 6% per year. So my rate is 6%. Again, we need to convert that to a decimal. So we do 6 divided by 100, which is 0.06. Okay, and it says it earned. Okay, it earned. That means we're adding to the amount that we started with. And so my rate is positive. And then it asks me how much is in the account at the end of 3 years. Okay. So then, again, at that point, it becomes a substitution problem. So I would have A equals 50,000 times E raised to the 0.06 times 3 years. And so there's the substitution. And then again, we walk it through the process on our calculator, again, I would start with doing the multiplication of 0.06 times 3. So if I pull up my calculator, I want to clear everything off the screen. I would do 0.06 times 3, which is 0.18. So I would have at this point 50,000 50,000 times e to the 0.18. Then the next calculations I'm going to do is I'm going to do this e to the 0.18. So again, I'm going to pull my calculator up. So I have second ln, the e pops up, 0.18, close the parentheses and enter. And so I'm going to have 50,000 times that decimal number. So I would have 50,000 times 1 point, and I forgot what my decimal was, so let me look, 1.1972, and so forth. Again, it's just easier. That number is already in the calculator's brain, so we tell it to take that number times the 50,000, and we enter, and it gives me the answer. Okay, and again, if we look at it, we have $59,860.87. So I have 59,860, forgot my cents, and 87 cents. Okay, again, be careful because you are asked to round to the nearest dollar. Well, you have the 8 in the tenths place, so it's going to actually round up and be $59,861. That's how much would be in the account after 3 years. Okay, then the next question, the third one says, a bank loan was recently paid off over a period of 15 years for a total amount of $250,000. What was the original principal amount if the loan was compounded monthly at an interest rate of 4%? It says round to the nearest cent, and ideally you want to wait and do any kind of rounding till you get to the very last step or to your final answer. Now, one thing about this problem is we see the phrase compounded monthly. It no longer says continuously. So when you have a word like monthly or quarterly or annually, rather some word other than continuously, it's a different formula. That formula is A equals P times 1 plus R divided by N raised to the NT power. And again, one of the first things that I like to do is to identify the information. Now, this one's also a little bit different because as you read this, it says a bank loan was recently paid off over a period of 15 years. So 15 years represents the time for a total amount of $250. Okay. So that amount of $250 was actually what I paid at the end of the loan. Because then the question says, what was the original principal? So I don't know the principal. If a loan is compounded monthly, okay, monthly implies once a month, and there are 12 months in a year at a rate of 4% interest. Again, the interest needs to be converted to a decimal. We do that by dividing by 100. And then we're going to substitute those numbers into the formula. Now this one again is a little bit different because we end up with $250,000. I don't know the principal, so we have 1 plus 0.04 divided by 12 raised to the 12 times 15 power. Now here again, if you're one of those that likes to try to put it in your calculator all at one time, that can be very challenging, especially with all these parentheses and exponents and that kind of thing. So I much prefer to kind of walk it through in my calculator step by step. And each number kind of gets remembered in my calculator. So if I'm thinking about this one, again, thinking about my order of operations, I would deal with the exponent first. Really, we would do parentheses first. So we're going to do 0.04. Let's do the exponent first, okay? It doesn't matter. That way I already have it. So I have 0.04 divided by 12, and I want to do 12 times 15. Okay, so I'm going to clear out my calculator. I have 12 for the compounding, 12 times a year times 15 years. That's 180. Okay, then I want to deal with the parentheses. So I have 250,000 equals P times 1 plus, and I'm going to need to do the division, 0.04 divided by 12, which gives me 0.003, repeating, raised to the 180th. Now, again, that's in the computer's or in the calculator's brain. So I have 250,000 is P. I'm going to add those two together. So I have 1.0033333, repeating, raised to the 180th. Now, I did that addition in my head, but on my calculator, I can simply say, take the answer, add 1, okay, which gives me 1.0033333. Then I need to raise that to the 180th power because I'm still dealing with those. So I'm going to raise that to the 180th power. Okay, so I would have at that point 250,000 equals P times, let me go back and get that number, 1.8203. Okay, you want to keep the entire decimal. And I'm trying to solve for P. Okay, so basically to solve for P, I then need to divide both sides by 1.8203. So I have P equals, I want to do 250,000, so I'm going to go 250,000 divided by, and I'm going to put that answer in there. Okay, so we press the blue second button and then the little negative key down next to the decimal, and it's going to automatically pop in that 1.8203001627, and I can press enter, and it gives me the answer. So I have $137,339.88. Okay, so I have $137,339. Did I say 87 cents? Let's see. 88 cents because the 6 is going to bump the 7. So it wanted us to round it to the nearest cent. So this would be to 88 cents. Okay, so there was initially $137,339.88 deposited into the account. Okay, one more. It says an initial investment of $100,000 at 12% interest is compounded weekly. What will the investment be worth in 30 years? It says round to the nearest dollar. Guys, it's important that you pay attention to how they want you to input things. So again, I see this phrase, compounded weekly, which lets me know the formula to use. The formula is going to be A equals P times 1 plus R divided by N raised to the NT power. And the second thing that I want to do is I want to identify all the pieces that I've been given in the problem. And it says an investment of $100,000. So that's my initial amount, or my principal is $100,000 at 12% interest. So we have 12% as our interest. Written as a decimal, 12 divided by 100 is 0.12. Compounded weekly, okay, so N is weekly, and in a year it tells us to use 52 weeks, and it wants to know how much the amount will be in 30 years. Okay, so once you've identified all the pieces, then you want to substitute it into the formula. So I would have 100,000 times 1 plus 0.12 divided by 52 raised to the 52 times 30 power. And then I'm going to begin the walkthrough on my calculator. So I would have 100,000 times 1 plus 0.12 divided by 52. And I need to do 52 times 30 to get my exponent. 52 times 30 is 1,560. Okay, continuing the walkthrough to get my numbers, I have 100,000 times 1 plus, I need to do the division, okay, 0.12 divided by 52 is 0.0023 and a big long decimal. And again, that's in my calculator's brain, okay, so I'm going to kind of keep it there, and I'm going to add the 1, okay, so that I have 100,000 times 1.00230 raised to the 1,560th power. Okay, now my calculator, that decimal value is already in the brain. We add 1, get the answer. Then we have to raise the answer to the 1,560th power. Okay, and when I do that, we have 36.44. Okay, so we're going to have 100,000 times 36.44. And again, you want to carry all the decimals out. It's already in the brain. 675. Then we're going to multiply it, in this case, by 100,000. So we do times 100,000 equals 3,645,670. Let's see, it would be 675.88. The 8 is going to bump the 5, so we're going to end up with $676. Okay, guys, with the word problems, as always, it's important. Take your time, read through them slowly, identify the information that you're given, and then basically do a walkthrough step-by-step process on your calculator.